Go ahead, Chaitra.
B, sir.
B. Okay. All of you agree that it is B? Okay. Let us rub the other things off. Maybe B or maybe D. Both are looking very, very similar. And bacterial systems can grow like A. You have something like this also. It's something called here with time old age. We call it senescence. When senescence sets in, then the growth can perhaps decrease also. So it is possible that it can be either this way or that way. But what is important for us is to know how is it that we can sort of delineate these kind of things and understand how the plants are actually growing. So when we look at this entire thing, forget about the senescence, and if you sort of leave about this particular curve here, therefore we believe that the growth rate is something like this, then there is no irreversible change. It is not an irreversible increase. Here, there is no increase here. There is no increase here. In both the places, the organism is growing. Do you understand what I'm saying? There is no growth here, there is no growth here. This is called as the lag phase. This is called the stationary phase. And this we call as the logarithmic phase. Everything happened very rapidly, exponentially things started growing. But then it will reach some kind of a saturation, or you reach some kind of a ceiling or a plateau that you reach here. But still the organism is growing. Therefore, defining growth is actually a very difficult thing. We cannot say it is irreversible. You create some kind of a stress here at any stage, it can decrease. It is reduction in growth. Growth is some kind of a mechanism where there is a change in metabolism. Maybe we can say that. So if there is a change in the metabolic activity, then the organism is growing. Whether it is putting up more biomass or it is putting less number of biomass or whatever it is. Now the question therefore is, if there is metabolism, then there is biomass. Now what is biomass? What is biomass? What do you think it is? Come on.
So the living matter, total amount of living matter of plants or any other organism.
I'll finish the class until you. Okay. What is it better? Sorry.
So the total that living matter which is present in any organism. So
Fantastic. So what do you mean living matter? What really do you think is a living matter? Good, I agree with that. I'm going to
that
next.
constituents like carbon and other components which are present, the minerals and all, maybe so.
Very good. So instead of telling that these are living matter, can I say it is a composition of the organism? Okay. Instead of calling them living matter, I would say they are organic composition of the organism, which is made of inorganic substances. All right. So basically, what happens is you have inorganic substances, and these inorganic substances are converted into organic substances. And for this, there is an input of energy. We need energy for this. So if you write this in another way, what happens is biomass is the complete total composition of an organism that is living in that space. Therefore, you call that as mass because of the composition. In physics, they told you what is the difference between weight and mass.
So weight is due to gravity.
What's that?
Weight is due to the action of gravity, whereas mass is the actual composition which you have. So all the tissues and living tissues.
Very good, boys. It is the composition. This is constant. Do you agree? But mass into gravity is equal to weight. Weight can vary because you take the same compound, take to moon, keep it on Earth, or take it to Jupiter. Where do you think it will weigh more, Jupiter or Earth?
Earth.
Think.
So it depends upon gravity. Where gravity is more, there now it is more.
Huh? Hello? Yeah, go ahead, go ahead. Where do you think the gravity is more, Earth or Jupiter?
Earth or Jupiter is a like gas bubble.
Hold on, okay. Okay, they say Jupiter is the more dense planet. So the
Depend on
gravitation,
mass and radius.
what is it, Gopal?
So depend on their mass and radius, sir. Gravity.
Okay, where is it high?
Sir, I think at Jupiter.
Okay, very good. It is. Jupiter is about 10 to 11 or 15 times more gravitationally greater than Earth. So you take 1 kilogram of something from Earth and keep it on Jupiter, it will weigh 10 to 15 kgs. Whereas if you take it to Moon, it will weigh less. That's because the weight is a function of gravity, which pulls it down, but mass is constant. So we are looking for mass, which we call as biomass, because we are converting all the inorganic substances, and the plant makes it into some kind of an organic substance. And the organic composition is what we are interested in, which determines growth. As long as organisms are capable of making or breaking these compositions or organic matter or the biomass, we call them the plant is growing or organism is growing. Otherwise, they die. If there's a dead organism, there is no metabolism inside this. Therefore, I would prefer calling defining growth with metabolism rather than on any of the increase in size. Irreversible. That's another thing that you tell. Why not it is reversible? For example, if me, for example, I'm a little bigger than all of you. Do you think if I do my exercises, I cannot reduce? I can, but I'll still be growing. That's what I mean. So when you now look at this growth, what is important for us is to explain how the organism grows and what really do we mean by metabolism. If several of you come to master's program, we will go into the depths of all this metabolism and understand how the plants do this. But at this stage, we will have to document this until that we can sort of understand what a real metabolism is. I'm sure you will be able to define what is metabolism in your own ways. Don't you worry at all about being accurate.
Sir, the total sum of all the reactions taking place in a living organism is called metabolism.
Fantastic. So all the reactions is what he says. Can you improve it? Can anybody help him to improve what Dinesh said?
Sir, anabolism and catabolism both are come in metabolism.
Acha. So you have anabolism and you have catabolism. Do you know what is cannibalism?
No, sir.
Sir, eating organism of the same species, sir.
Okay. So it is not metabolism, right?
Yes, sir.
Okay. Good. So you have anabolism and catabolism. Do you know what that is? What is anabolic activity? What is catabolic activity? Very good.
Sir, catabolism means breakdown, sir. Anabolism means absorption of those particles.
Okay, you make in anabolic activities and you break in catabolic activities. Do you think they always happen or one after the other? That both anabolic and catabolic activities go on at the same time, or one period this, next period something? What do you think?
They will go together.
Very good. So they always happen together. That means whether it is making some organic matter or breaking those organic molecules to derive whatever they want, they are always metabolizing. So these, he says that it is all the reactions put together, all the anabolic, metabolic reactions put together is metabolism. I would simply call, because they are all taking place in living organisms, I would call it as all the biochemical activities, reactions that are taking place. Is that okay if I say that? Instead of reactions, I will say biochemical reactions, just a little better.
Yes, sir.
Okay. I will tell you one more difficult thing in this. Not a difficult thing. One more word to make it a little better than what we studied in 8th standard. All the biochemical and all the biophysical reactions will lead to metabolism. Now, what the hell is biophysical? But biochemical, I understand. What is biophysical? Go ahead. I mean, everybody should interact, Makle. Try that because see, in this online damn things, it is very hard that we learn. It's very hard because you don't have practicals at all, which is actually really bothering us. But but then interact. At least that part of it, let's learn. Go ahead.
Sir, sir,
Hello.
mastication of food, which is a physical thing taking place in a living organism, sir. So I think it's biophysical.
Okay. So physical activity such as what? Let us now put this way and then go ahead and learn each of those things. We said that there are resources that we require. Okay? Resources such as water, light, nutrients, carbon dioxide. This is what you said. These are important resources, no doubt about it. None of them are biological, isn't it? None of them are organic at all. These are also some kind of, if they have to be used by the plant, that means there are two things that has to happen. A, when I use, how do I use? So before you use, you have two very, very important things that are happening. One is acquire. Acquisition is important. That means you go there, absorb, or you accept, or whatever it is. You should eat, you should take it in. And after that, you have to metabolize them. Metabolize or basically utilize. That is all what we have to understand. But when we go to the higher studies, we know that there is acquisition, there is utilization, and then there is something that happens in between the two of them is to make it more efficient. Okay. So now what we are trying to do is, if we are trying to now absorb or utilize or acquire and utilize, then acquisition happens when these resources are mobilized or moved towards, let us say, the plant. Now, this movement is the most important thing that we need to remember, that this movement is a process that we call as diffusion. What is diffusion?
Sir, movement of gas from high concentration to low concentration.
Okay. So do you agree with what Gopal says? Movement of gas from high concentration to low concentration. Do you agree?
Diffusion can be of so any substance, like, but we call it by different terms. So
Fantastic. So he called it gas. Anything, any molecule, correct? Whether it is gas or liquid or solid things, any molecule will diffuse from a higher concentration to lower concentration, correct? Yes?
yes, so
Yes. Now, there are two questions that we need to answer. These are physical reactions, but these physical reactions take place inside a biological organism. Therefore, we call it as biophysical processes. Physiology is a combination of both biophysics and biochemistry. But biochemistry, they study only biochemistry. They don't worry about all these diffusive activities. I will tell you many things that we go on, and we can discuss about those things. Whether it is nutrient or CO2 or water, you will have to diffuse from one place to another. But what about light? What do you know about light?
Sir, it is absorbed.
Okay, we'll come to that absorption of light and all that, but I'm asking you, what is light?
Energy is form of energy.
Okay, it is a form of energy. Agreed. And then ಏನ್ ಗೊತ್ತಿದೆ ಎಲ್ಲ ಹೇಳಿ. Go ahead. It is made of some packets called photons. It is produced by an atomic reaction called atomic what? Atomic fusion. It is propagated as a linear thing. It is a linear. So it is moved as waves. Light travels as waves. And light energy is inversely proportional to the frequency. You remember all those?
Yes,
Yes,
sir.
sir.
Yes, you do. ಅದು ಯಾಕೆ ಹೇಳಲಿಲ್ಲ? Okay, doesn't matter. Okay, so you have these things which are happening this way. What is important is when these nutrients or resources like water, nutrients, CO2 or anything is diffusing, they have a mechanism which governs that property. But after that, if the plants absorb them, accept and absorb them, how is it that they are used in the next step? When you do the metabolism is what we need to understand in the entire plant physiology course. If you take any one of them right now, let us say you looked at water. Now, the question that we have is, what is water? Did they tell you that in school? I am in the middle of water. Who am I? This is I don't know. You guys are brilliant. Maybe third standard you would have done. I did it in 8th standard. I am in the middle of water. Who am I? Akul. Govind. Huh? Oxygen. Okay. Answer. Let us write
Sir,
answer.
letter T, sir.
Okay. Now somebody said oxygen, someone says T. What do you think? I am in the middle of water. WAER. So letter T. So that's all. Okay. I mean, that's jokes. When you look at this water, water is oxygen, correct? No doubt about it. It is a hydride of oxygen.
Two.
You have two molecules of hydrogen, two atoms of hydrogen attached to one molecule of oxygen to give you the water. Oh, there is something that I want you to realize, understand very carefully. There are two processes that result in most of the biochemical or even chemical reactions. And the two most important processes are oxidation and what is the other one?
Reduction.
Yeah. Can you see the board? Can you make out what I have written?
Yes, sir.
Yes. So your oxidation and the reduction processes which will make it. Now, what do you mean oxidation? What do you mean reduction? Go ahead with the oxidation. What is oxidation?
Sir, addition of oxygen, removal of electrons,
Wow.
removal of hydrogen H plus ions.
Oh, wow, very good. So removal of electrons. If you take electrons and you remove electrons, let us say from a molecule, let us say there is this molecule M. This M, you have taken away an electron. What happens to this molecule now if you take away electrons?
M plus.
Yeah. So M plus, very good. So M plus is oxidized or reduced?
Oxidized.
Sure. Akash. Are you sure? Bhuvana? Do you think Akash is correct? Okay. Hey, are you guys, is it, I mean, why? Bhuvana, are you there?
Yes, sir.
Okay, what do you think? Is Akash right or wrong?
Akshat, sir.
Huh? If M becomes M plus, M gets oxidized to become M plus, or M becomes reduced to become M plus.
It is oxidation.
Oxidation. Oxidation, sir. It's.
Sure?
Yes, sir. 100%.
100%. Oh, very good. So this is oxidation. But if I add an electron to this M, if I add an electron, this M becomes M minus, this is reduced. That means you have only been adding or removing electrons. Therefore, how do these electrons come in the way? And where is the source of electrons? And who actually makes them to now give away the electrons? This is the question that we have. And one of the most important sources of electron for all our higher planet systems is water. Okay? Now water we know is H2O. And it is called, it is a oxygen dihydride, or it is dihydrate, is called water in chemical terms. This hydrogen, which is sitting with oxygen, is not in this fashion at all. If water were to be some such a physical damn thing, I don't think life would have evolved at all on Earth. What life is all about is that you have the oxygen atom like this, and every molecule, every atom has something called as valency. Know what is valency?
Number of electrons in the outer shell.
Number of, just not the electrons on the outer shell, correct? Binesh, correct? But what is actually more correct, Helrona?
It's a combining capacity of any element, sir.
Yes. So it is binding capacity, or how do you bind? Make it a little better, Ankita. Correct, correct. It's binding. But what is it? How is it?
Number of bonds formed with the other element.
Ah, very good. Now, how do they bond? How do they make the bonds with other molecules? Akash.
Sir, either by sharing the electrons or by donating the electrons.
Fantastic. Very good. And I wish I see you guys. I love this class. Very good.
Shall we
Therefore,
open?
huh?
Nothing, sir, nothing.
Hey, hello. What do you say, Devendra?
Nothing, sir, nothing, sir.
How can it be, man?
Sir, I was just saying,
You're just saying what better?
sir, oxygen and hydrogen only.
Okay. So valency is number of the replaceable electrons at the outermost orbit of the atom. Okay. So you share, you give something and all that. But this damn oxygen molecule has some mechanism where they can share it, they can make bonds, but they will tell you where to sit down. That's amazing. I really do not know how this damn nature designed this. In the sense, oxygen has two valent electrons. That means hydrogen, this is for oxygen, and for hydrogen, you have one valent electron. That means I have two electrons to share, and I need only one. You have two, I need only one. But me and my another fellow like me also wants only one, means oxygen can bond and share electrons with two atoms of hydrogen. You agree?
Yes.
If they had made like this is one, this is another one, and then hydrogen here, life have not existed. I don't know why it did not happen like this. What happened was amazing. It was not like this, but it became something like it shared with the hydrogen atom here, it shared with the hydrogen atom here, which means it became something like this. And the angle that it made between the two hydrogen atoms was dash 105 degrees. Why? Wow, this is amazing. Why did they make it like this? Now, because of this structure, it developed certain properties of water. Now, one of the most important property that it developed was that you have a positive charge on one end, and to balance the positive charge of that one end, oxygen atom or oxygen atom developed two negative charges on the other side. So electrostatically, water molecule is neutral. That means the number of charges that are positive is equal to the number of negative charges. So once you have like this, then you have a negatively charged surface and a positively charged surface. This resulted in what we call as bipolar nature of water. So one of the most important properties of water is that it is bipolar. It has two poles, positive and negative poles. Because of this bipolar nature, it develops a very, very important property number two called it has a very high dielectric constant. Dielectric constant is the ability, how much power, how much energy, electrical energy is required to break this molecule. Unfortunately or fortunately, it is not at all easy to break this molecule of water. Because of these two important properties, it developed other properties such as it has a very high cohesive force, cohesion and adhesion. You know what is the difference between cohesive and adhesive forces? Yeah,
Yes, sir.
what is it?
The cohesion is the like interaction between within the same molecules, whereas adhesion is the interaction between different molecules.
Very good. So cohesion is similar molecules. That means water molecules attract each other. Adhesion is dissimilar molecules. That means that's the reason why you add water to your hand becomes wet. But if you keep mercury will not touch you at all. It will go away. It has zero adhesion, mercury and something else. But some molecules don't have any cohesion at all. Unfortunately or beautifully, fortunately for us, water molecule has high cohesion and high adhesion. Therefore, we call it together as it has a high what we call as a tensile strength. It has high tensile strength. Tenacity is very high. You pull it will be there, you shrink it will be there. But unfortunately, this damn thing does not change at all. Water is the only liquid that remains a liquid for a very large range in the temperature between dash and dash degrees centigrade. Water is the only molecule that has so much of a range where it remains temperature range where it can remain a liquid. What is that? Can you fill up the blank?
4 degrees Celsius to 100 degrees.
Okay. Option A, 4 degrees to 100 degrees. Anybody?
Sir, 0 degree to 100 degrees, sir.
Wow. 0 and 100 degrees. Now, who is more correct? Makle. Think. Akash, you said 4 degrees, right? Who said 4? I mean, it's not
Sir,
wrong. Huh?
Devendra sir.
There, very good. So it is not wrong, beta. What do you think it is? What is 4 degrees? Have you heard about what is called as
Anomalous expansion.
Very good. What is that?
So at this degree, the water starts freezing, but it actually, like in freezing process, we see the contraction, the coming of a molecules, but rather in water, it just opposites. It start expanding, sir.
What happens to the water at 4 degrees centigrade is that the density of water is maximum at 4 degrees centigrade. After that, it expands on either side. Decrease the temperature, it expands. Increase the temperature, it expands. So the density of water, what is the density of water?
1.
1 is at 4 degrees centigrade. After beyond 4 degrees, less than 4 degrees, the damn thing changes. So at 4 degrees centigrade, that's the most beautiful thing. How did it happen? Wow. This is the reason why aquatic organisms can still survive. So the moment it becomes solid, freezes, the temperature becomes zero, less than zero, then it becomes lighter and it floats. Ice floats on the surface of water because the ice cube is less dense compared to the water, and therefore it insulates it. Therefore, the benthic water in the sea does not freeze. It can happen if the temperature becomes extremely low, like what happens in the glaciers that you see in the poles and other places where the temperatures are very, very low, minus 50 degrees centigrade. Then there a lot of distance can be, like we have the Siachen glacier in the Himalayas. Temperatures are very low there. Okay, but remember, water remains liquid between 0 and 100 degrees centigrade, Devendra. It's not 4 degrees. Even below 4 degrees, water remains a liquid up to 0 degrees. Anything less than 0, it solidifies, becomes ice. Anything above 100 degrees, it changes its form to vapor. So you have a whole lot of these kind of things that happens here. Now, because of these few properties of water, there are a large number of very, very important functions for water. And that's all what we need to understand in this particular course, that what are the functions of water? How does it help the plant to grow? How does it help the plant to pick up other kind of things and then start growing? Do you understand this, everybody?
Yes, sir.
Okay. So now when you look at these properties that we said just now, and then we look at the functions, what do you think should be the function of water?
Sir, universal solvent.
Very good. So the function that you have should entirely depend on the properties. That is all what we have to remember. See, it's something like this. I'm sure after your graduation from the agricultural universities, some of you want to be civil servants, some of you want to get jobs, some of you will become entrepreneurs, and somebody will become scientists, somebody will become teachers like us. I'm sure all of you have some kind of a dream that is forming in your mind, correct? Say yes at this moment. I'm
Yes.
not asking you what is it, yes. But remember this, Matlab, only one thing remember. The job that you get is your function. That is what you will perform. After, let us say, 3 years from now, you will be a graduate and then do so many things. That's function. But for that function to happen properly, your properties today should be very, very good. That's all I'm saying. Spend every time that you have. I'm not saying you should become saint, you should sit in one corner, only study and nothing else. Nonsense. I have never done that in all my life. Don't do that. But ensure that whatever that you do it with absolute concentration. Once you do that, your functions later on will be very, very easy. Look at this. He says it is a universal solvent. Very good. It's a universal solvent. Now, how does it become a universal solvent? Why is that other molecules are not universal solvents? Why water alone is? It is, correct. But of course, we will, as we go up and learn more, we will say, well, it's not really universal. Well, it is large number of molecules can dissolve. A large number of molecules can dissolve in water. How? How can that happen?
Bipolar nature.
Mhm.
Because
Well,
high constant.
what is that, Gopal?
Sir, because of high dielectric constant 82, sir.
Very good. So you have a very high dielectric constant. That is what he says. Do you agree? It has. See, what is it that means is when you dissolve, when you melt, it's something, let us say, you are a very stubborn person, you don't want to listen to anything, and somebody tells you a story, and some people don't laugh if you tell a joke, some people do not become sad when you tell a sad story, you don't get scared when you see horror movies. How many of you see horror movies? I see. I get scared, but do you see horror movies?
Yes, sir.
And you
Yes,
get
sir.
scared? How many
No,
of you
sir.
watch the horror movie alone?
Me, sir.
Very good. Really, you don't get scared, Devendra?
Sir, I see other stuff, sir. I don't get.
You don't get what?
I don't get scared. I see other stuff. Like I see how they are doing like that.
Acha, so you don't get really scared. Very good. So look at this. Let us say Devendra does not get scared when he sees horror movie. Devendra does not laugh when you tell a comic joke. Devendra does not become very sad when you tell a sad story. Is it possible, beta?
No, sir.
No. So now there is a mechanism. It is something like this. Let us say, if you ask me, I laugh at the smallest thing and I can cry at the smallest thing and I get scared in all the movies. So that means there is a small difference between me and Devendra. Do you agree? What I mean is, I melt easily. Devendra does not. But it does not mean that Devendra cannot be melted at all. You have to only increase the energy that you have in it. Maybe tell a bigger joke for him to cry, laugh. Maybe make it very horror to make him get scared. But for me, it is very easy. Ting, I get scared. Ting, I laugh. Ting, I cry. But for him, that kind of thing you have to do. Which means every molecule that you look at can dissolve, provided you provide the energy that is required to make those bonds, to sort of make them into some kind of a things where you did talk about what is called a solution and colloids. When you come to the practicals, we'll do those kind of things. I hope you do that. Therefore, that all becomes in such a way that if you put this compound into water, it has to be broken down into smaller and smaller particles, and therefore you can actually dissolve them. Both of them are suspensions. They both are suspended in water, suspended in water, so that they remain stable. But if you put sand in water and stir it, then it will stay for some time, but it will settle down. That is a temporary suspension. Permanently suspended solution of colloids are possible only when you provide the energy that is required to dissolve the molecule. If you dissolve the molecule, and that's the reason why it is the most important factor that determines the universal solvent property of or the function of water is the high dielectric constant that it has. This dielectric constant comes because of the high bipolar nature of this molecule. Bipolar nature in the sense it can neutralize and suspend both positive and negatively charged molecules. So I'm sure you talked about what is called, you take a molecule and put it in water, either it dissolves or it gets ionized. Correct? What is the process of, when you put it in water, it gets ionized. It's called what? Ionization, isn't it? So suppose you take sodium chloride and put it in water, it becomes sodium and chloride ions. So you call them as cations and anions. It moves to the cathode and anode, positive, negative charges, blah, blah, blah. So you know these kind of things, right? Yes or no?
Yes, sir.
Yes. So what happened? This property that it is a universal solvent, it's all because of this. Now the question that we have is, who the hell bothers about this fellow water becoming a universal solvent? I don't care. Because my job here is to understand how it can help plant physiology. But who the hell is bothered about the damn thing dissolves some sodium chloride and some bullshit? Who cares? I don't care. If I say that, no. We have to understand this because what are we dissolving? What are the molecules that we are dissolving? Must be some of these things which are used as resources for your metabolism. It could be the dissolution of the nutrient element. It could be the dissolution of carbon dioxide in water. it could be any damn thing that you look at. Water becomes the most important material that is required for the functions of the plant. Because besides all these things, it dissolves the resources. Number one is it's a solvent that is used, but in very, very different processes, water is also a substrate for the metabolism. And the most important process is photosynthesis. We will discuss about this, how water can become a substrate for photosynthesis. And then very sorry. And the very, very important function that we have for water is to transport food, nutrients, and all other resources from one place to another place in the plant is possible only with water. We will talk about later on how the xylem helps movement, how the phloem movement takes place, how it helps the growth hormone. We'll see later on slowly. But when you look at the other things that are important, it is most important in keeping the camp cooler. One of the most important properties, functions of water is what is called as evaporative cooling. But if you realize very carefully, Makle, all these processes, including the water becoming a substrate with photosynthesis, are biophysical phenomena. There is no biology in this at all. It dissolves because of the energy that it has for the dielectric constant issues. It can transport physically. I am moving, I'll carry you. So it's physical. I don't have any relation with you, but you can go with me and I will drop you wherever you're going because I'm going that way. Cooling by evaporation is an absolutely physical process, but that has a tremendous indirect advantage for the plant in terms of its entire metabolism. We will see that in the next class. All right? Okay. Do you have anything to ask me, Maple? Hello?
Sir,
Yeah. Go ahead. You want to say see, last 2-3 minutes or 5 minutes, I want to keep for this kind of discussion that we can have. Because let it not be a one-way traffic where I say something and you grab something and you don't care about each other. This is not correct. What do you say, Aishwarya?
Sir,
Oh, there are two Aishwaryas. Very good. All right, go ahead. What do you say? You agree with me or disagree with me?
yes, sir.
Yes for what? Yes, I disagree. Yes, I agree. What are the yes are for?
Agree, sir.
You agree for what? Say that. You agree that we should discuss, Alwa?
Yes, sir.
Now ask. Now you agreed. You ask me, tell me. What did you learn? What did you not learn? What did you like? What did you not like? How much of something that I told today you already knew? Everything, I guess. Alwa? Where? Hey, man, come on. Chandan. Keen Victor. Yeah, what do you want to ask or say something? You see, every time, I mean, though I taught this course umpteen number of times, but it always gives me a lot of happiness when I see young people. And every year I go to teach there, I see only younger people. Next year it will be still younger than you guys. And I like it that way. You grow old and I am growing younger. Correct, Allah? Correct, Anusha? Hey, mute spectators. Others.
yes, sir.
Yeah. Go ahead. Why are you silent today? Okay. So tomorrow is your Republic Day. Have fun, enjoy. It's a good that India is a democratic republic. Okay. And we require a lot of energy from each of us to do things for the country. All right. So
Yes, sir.
you have nothing else to ask. Bye bye.
Okay, sir. Sir, thank you, sir.
Not
Thank you,
at all, not at all, my dear boy. It's a pleasure. It's a pleasure. It will be much better if you all of you can interact and tell me something. I know that if everybody talks, it will be a noise, but you can always do these things, until we hope we meet sometime. Okay, Makle.
Okay,
Bye
sir.
bye.
Bye, sir. Bye, sir.
Bye.